Hello and welcome to Lesson 10.2 Graphing Square Root Functions. Today we'll be going over the Explore section as well as several explain problems. So the first thing we see is it says Explore graphing and analyzing the parent square function. So here it says the domain of square root functions are limited to real numbers is given by, we talked about that only positive numbers for this case will be accepted positive numbers. And we talked about this in class on the previous lesson, so that x, which is the domain, so all our x values will be greater than or equal to 0. Because all positive numbers, if you think about it, like 1, 2, 3, 4, and so on, are greater than 0. And we can also include 0 as an actual real number as well. Alright, so it has us fill in the table. It gives us some values for x. So what we're going to do is we're going to square root 0, and we're going to square root 1, and square root 4, and square root 9. So if you need to, go ahead on your calculator and work that out. And we will write in the square root of 0 would be 0, 1, 2, and 3. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, and the square root of 9 is 3. Where they're going to take some time to plot these points. So here that would be 0, 0. The next one would be 1, 1. The next one would be 2, 3, 4, 1. So I just like to label these as well. It takes some time, it works it out. So that way it's a little easier to graph. That would be 4, 2. And last but not least, 5, 6, 7, 8. That would make this 9. 9 and 3. And I'm just going to draw a connecting curve, and I have my graph for part C. Alright, continuing on. It says, recall that this function is the inverse parent function of f of x equals x to the second power, with the domain limited to non-negative real numbers. So that means positive numbers only. And we talked about this in the last lesson, how y, which is our range, all y values, so all these y values are going to be all the numbers that are greater than or equal to 0. It says the graph appears to be getting flatter as x increases. In fact, as you can see here as my kind of recreation of that graph, it kind of shows that it kind of plateaus or flattens, just like it says, as x becomes larger. So it says indicating that the rate of change blank as x increases. So the rate of change isn't really going up, it's actually decreasing as x increases. Last but not least, for part F, it says describe the end behavior for the square root function f of x equals square root of x. So, as f of x grows to a certain value, as x grows to a certain value. So what that means is as f of x, which is our kind of our y value, becomes greater or goes up infinitely, so goes up infinitely, and there's a fancy way we can write this, infinitely, which is kind of like a sideways 8, or in the infinity symbol. as x becomes greater, or I should say infinitely greater. And even though it is flattening out, it is still becoming more, and same thing here, it's still becoming more. Okay. So now we're going to do some explains. This is actually taken from your textbook, and this is actually something in your textbook that's useful for identifying certain values and helping us graph. So it says, for each of the transformed square root functions, find the transformed reference points. Use them to plot the transformed function on the same graph with the parent function. Describe the domain and range. Alright, so this is again taken from a table in your textbook. So we have g of x equals our a value, square root x minus h plus k. So the first thing I'm going to do is identify my a value, which appears to be 2. My h value, which appears to be 3. And then my k value, which is actually not a positive at all. In fact, it's a negative 2. Okay, so here if you see your reference points were 0, 0, and 1, 1, much like we saw in the parent function, 0, 0, and 1, 1. We're going to transform it so that way we kind of match some of the values. For h and k, h was 3 and k was negative 2. For h, that would be 3 plus 1. And for k, that would be negative 2 plus 2, which if I simplified this out, my 2 points would be this first one and 4, 0. And what I can use is use those 2 points to graph this function on the next page. So that would be 3, negative 2, and 4, 0. So that would be 3, negative 2, and 4, 0. So you'll notice here that the function has kind of shifted. So those two are a little different. We can also use Desmos, just like it says here, to check our reference points. So I will be doing that right now, using Desmos to check our equation, which was right here. G of x equals 2 rad x minus 3 minus 2. So I'm going to use Desmos to just check and my 2 reference values and to make sure I can have more points to write out our problem here. So let me just go ahead and do that, those 2 points. And let's go ahead and check to see if they're correct. So on your internet browser, you can type in desmos.com. When you do that, it'll bring you to this page. We're going to go ahead and press Start Graphing. And I'm going to enter in my equation. Instead of writing g of x, I will write the letter y. Again, you notice how we can use that keyboard. Y equals 2 square root x minus 3. And notice how I clicked outside of my radical so I can write the minus 2. And you'll notice here my 2 reference points are 3, negative 2, cool, and 4, 0. If I continued on, you would see I have a couple more points that I can kind of use to plot this out, but essentially my graph would look something like, as I'm trying to zoom in and out, just so I can have a little bit of a graph here. That would be, so I'm going to go ahead and draw on here that graph. So I'm going to go ahead and maximize this and show you how to do that. So that would be a sketch of that. And then as you can see, it says the domain. The last thing we're going to do is describe the domain and range. So this is just a little shortcut for you. Domain is going to be all x values that are greater than or equal to your h value. And your range will be all your y values that are greater than or equal to your k value. So as you can see here, our h and k value were actually 3, -2. So that would be 3, -2. And you notice that that's actually the starting point for our graph. So domain is the smallest x value is 3, and the smallest y value is -2. So here's our next problem. Explain 1. Again, we're going to, for each of the transformed square root functions, we're going to find the transformed reference points and use them to plot the transformed function on the same graph. Describe the domain and range. So here you'll notice that our square root function actually looks a little different, so I pulled this from our textbook as well. So here you see that's 1 over b. So here I have 1 over -2. Our x minus h, or x minus 2, plus k. So that would be plus 1. So our reference points will change a little slightly. Our h and k will still be our first reference point, which would be 2, 1. Our h value was 2 plus -2, and our k value would be 1, right there, 1 plus 1. So if I simplified that further, that would be 0, 2. So using those 2 points, so we're going to graph those 2 points. This point was 2, 1. And the other point was 0, 2. So that would be 2, 1 and 0, 2. 2, 1. Sorry, it keeps going away on there. So that's 2, 1 and 0, 2. So before we go and verify these points, we are going to use our h and k value. Remember, our h value was 2, so that's the starting point or starting x value, and the k value was 1. That'll be our starting y value. Now I'm just going to check Desmos to make sure that that's correct. So I'm going to go ahead and keep that. Remember, our equation was, so I zoom in here, g of x equals square root of -half, parentheses x minus 2 plus 1. So I'm going to again open up Desmos. Again, you can type in that web address. And I'm not going to use g of x, I'm going to use y. I'm going to go ahead and write in square root 1 divided by -2, parentheses x minus 2, parentheses. I'm going to click out of the radical and write plus 1. As you can see here, that graph starts in one place and continues on. So we're going to go ahead and kind of draw a sketch of that on our graph. So it doesn't have to be perfect, but that's our sketch of that graph. So just as it says here, we're going to stop right here and we're going to do some problems out of the packet. Okay, so go ahead and do that.